Hey everyone, how's it going? First stream in a while, but we're back. I've been following the chat. Also, we gotta hydrate. Yeah, it's good to see everyone. Yeah, so this contest, I thought it was pretty hard. Like I had a lot of trouble with C and also D. And you can see it's a big drop off from B to C. But yeah, kind of funny. I definitely found E easier than C and D. Oh, Anand, thanks for the sub. Awesome. Um, yeah, A, I think A and well, B also had a bit of a trick too. So a lot of these problems, I don't know, a lot of these middle problems, I just found them pretty tricky. Um, in terms of standings, I think we had about 20 people solve everything, assuming sys tests hold up. I guess we were already into this. Oh, are these actual fails? No, this is accepted. Okay, so it's just the system test being silly. Okay, but we can come back to system test. Let's check the chat. Which extension am I using? This is Carrot. Hello Neil, congratulations for rank 1. I didn't get rank 1, I got 4th. TLE on E, yeah. For E you need to use, I think you need to use a seg tree for that problem. So we'll go over it. Can you explain A? Yeah, we'll go through each of the problems. Okay, seems like system tests are underway, so... And yeah, I had a wrong submit on, or not a wrong, but a TLE on B. This is the only failed submit that I had. But anyway, we can jump into the problems. So, let's see. Problem A. Problem A is a grid with 2 rows and n columns. And Alice fully covers this grid using n dominoes that are 1 by 2s. You can place them vertically or horizontally. And you got to cover every cell exactly once. And then you get 1 row of the grid, and you want to figure out the other row. So n isn't too big, only 100. And you get L, R, U, or D, which tells you kind of which half of the domino you're seeing. So yeah, as one example, if you get L, R, D, L, R, that means, because of the D, that means you got a bottom row. That means here, obviously, it's a U, and then you fill these with L, R, L, R. Basically, this problem is kind of tricky because there are a lot of cases that make the tiling invalid or impossible. You can't have both a U and a D in your row, for example. But they have a requirement, or they have a constraint, that the input is always valid. So for your solution, you actually don't have to worry about that. So basically, the only thing you have to do in this problem is you need to be able to handle both cases of you get the top row and you return the bottom row, or you get the bottom row and you return the top row. But all you have to do for that is, when you see a U, you need to flip it to a D. When you see a D, you need to flip it to a U. And then that's actually pretty much it. Otherwise, so my code is actually a little bit more complicated than necessary. Basically, yeah. So this is, I start with reading an S, and then I build a string T with question marks. When you see a U and S, you make a D and T. When you see a D and S, you make a U and T. And then otherwise, I fill in just, LRs. But you can actually just copy this from S. So you can actually do, let's see, I guess I can just modify my code in real time here. Yeah, this should work. So let's try that. Yeah, so this is an even better version of the solution. Okay, just catching up with chat right now. Yeah, SSRS did really well here. Just like this is a very dominating performance, finishing at 35 minutes when the next closest finish was 57 minutes, and then 1 hour 17. And I was actually kind of late on the finishing side. I finished at 1:31, which was 1 minute slower than Anand, but Anand has way worse penalty, so he's way down there instead. Yeah, basically I had reasonable times on A through E, and then took a while to do F. Looks like we got some Russian speakers in chat. I don't know what these are saying. And you can just scroll in chat, Ali Boss. We got another hydrate. Yeah, bold means the problem is locked, so people are trying to hack. I don't know if anyone actually got any hacks. We can try to like check that here. Yeah, it looks like there were 0 hacks in this entire contest, which is kind of boring. How do we test for wrong input cases in question A? So yeah, on problem A, you don't have to test for wrong inputs. You're just guaranteed that the inputs will be valid. That makes the problem a lot easier. If you had to test for all the inputs being valid, there would be a lot more cases here than just this. But as it is, you can just solve it like this. Okay, yeah, let's move on to problem B. So for problem B, you've got 2 integers A and B. A is greater than 0 and B is greater than or equal to 0. You make an array of non-negative integers with a mex of A and an XOR of B. And you want to know what's the shortest possible array. So mex means the minimum excluded value in the array. So for example, if you have an array of 0, 1, then the mex is 2. Or if you have an array of 0, 2020, 2021, then the mex is 1, because 1 is the smallest value that's missing. So basically, the mex constraint, it means that we have all the numbers 0 through A minus 1 in the array, and we do not have A in the array. And then we just want to make sure the XOR of everything equals B. Okay, and yeah, A and B are both up to 3 times 10 to the 5th. And you need to solve each of these test cases. So yeah, so basically we can start with this mex constraint. So we need to include everything from 0 through A minus 1. And let me see, in my first submission, that is what I'm doing. So I'm including everything from 0 through A minus 1 and getting the XOR of that. And then you need to add potentially more things in order to XOR to B. So there's a couple cases. If your XOR is already B, then you're done and your answer is just A. If your XOR, so I XOR the full XOR with B to see what I still need. So if I need 0 after that, then the answer is just A. Otherwise, the answer is generally 1 because there's one number, or like there's one value you need, and you just include that number. The only problem is if that number that you need is A itself. And in that case, you need 2 because you need to avoid A based on this max constraint. So yeah, to try to summarize that, basically, we're going to start with all the numbers 0 through A minus 1, take their XOR. If XOR equals B, then you're done, and that's your array. If XOR equals B XOR A, then you have a problem where you cannot solve it with one number. But if XOR is not equal to B XOR A, then you add the XOR number itself to the array, and then you're done. Otherwise, you need 2 numbers. And you know, you can find a lot of ways to to get two numbers that XOR to A. One example is you can pick 1 and A XOR 1. And both of these should be not equal to A, unless A is 1. I mean, in any case, you can just pick a huge number. You can pick a huge number and then A XOR a huge number, and then neither of those will be equal to A, guaranteed. So this is what the code does. First we can look at this submission. Basically, we take the XOR of 0 through A minus 1. We XOR that with B. That's the amount we still need. If the XOR is 0, we end up with 0. If the XOR is not 0 and it's not A, we end up with 1. And if it is A, we end up with 2. We add that to A, and that's how many we need. The problem is this gets TLE, because the problem is it's a little bit of a trick where you have 3 times 10 to the 5th, which is fine to do a loop, but you have 5 times 10 to the 4th test cases, so you can't actually do that. So there's 2 ways to fix this. One is, well, you just need prefix XORs, right? All of the first A numbers. So you can pre-compute an array up to 3 times 10 to the 5th of all of those prefix XORs and just look up in the array. And then the other thing you can do is, this is what I did in the contest. You can actually compute the XOR of 1 through n in O of 1 time. It basically only depends on n mod 4. The reason for that is if you take 4 numbers in a row, for example, you have the number like this, and then you take, so this number is 0 mod 4, this is 1 mod 4, this is 2 mod 4, and this is 3 mod 4. What you'll notice is that all of this stuff just cancels out, right? If we XOR these 4 numbers, all of this stuff cancels out because it all appears 4 times. And then each of these bits also appear twice as a 1 and twice as a 0, so they all cancel out as well. So yeah, basically you have 4 cases to compute the XOR of 1 through n. It just depends on n mod 4. And that's what I do here. Okay, catching up on chat. Nuzgoal says, I thought this question was poorly worded. Which question are you talking about? Are you talking about A or B? Missed problem A discussion. Yeah, you can check the video here. Oh, my title is super wrong. Let me go fix that. Okay, the title is now the right round number. I used Python. This method was too slow in Python. Well, it was also too slow in C++, so don't worry. It wasn't because of Python. Seems like some people missed. Yeah, there are 3 different cases here. Why didn't you pre-compute? Yeah, that would also work. I don't know. I just thought it was a little silly, so I just went and did this. But this is probably more error prone, so pre-computing is better if you're trying to stay safe. Okay, KP55, you're kind of spamming tips for becoming a certain rank. I don't think anyone can really give you a tip for becoming a certain rank. I think they can only give you tips for improving from where you are. Why is it? Oh yeah, with XOR, you do need to be careful of operator precedence. So for example, if you're trying to do A XOR B equals C, let's say you're doing an if, the problem is this is actually you're actually XORing with the equality comparison before the XOR. You need to parenthesize your XOR. That's because XOR is often used for Boolean logic like that. We got another hydrate. My voice is very low. What do you mean? Do you mean you can't hear me? Someone AC'd with a loop because of progbuzz. I see. Okay, yeah, that's definitely possible, but it's not something you want to depend on. Okay, sounds good. We can go to C. If you're still confused about B, you can check the video linked here. Unfortunately, it has the wrong title because I didn't update the title before starting. I think it says 708 instead of 742. Maybe that guy was saying my voice is low pitched. I don't know. Anyway, okay, problem C. Yeah, so this was a hard problem. I took a while to solve this problem. So basically, this, you know, on it says, "Can you make your voice a little higher pitched?" Maybe next time. Helium, please. Yeah. So okay. So this person adds very weird. Instead of carrying to the next digit, they carry 2 digits over. So this 9 plus 6 gives you 15. So they put a 5 here, and then they put a 1. Sorry, they put a 1 up here instead of up here where it should be. And instead of getting 5,015, they end up getting 15,005. So you actually start with the number that you get as a sum, and you want to figure out how many pairs of numbers could Alice have had where when she does her special way of adding, she gets the sum. Yeah, exactly. C and D felt very similar. Like they were both about carrying digits, all of that stuff. Anyway, so we want to know how many ways we can get this sum. Yeah, I mean, I stared at this problem for a while. I eventually decided to do an exponential on the number of digits. So Alex sucks at math. Yeah, exactly. I decided to do an exponential on the number of digits. So basically I take the number of digits. I do 2 to the number of digits. I'm just deciding which positions is she going to do a carry at, and then this is like, I knew this wasn't the best solution because I mean if you're looking at the scoreboard, people are solving this problem, and you know, SSRS did this problem in 3 minutes, right? This person DLAL swap did it in 5 minutes. You know, other people like 4 minutes. You know, 8 minutes, things like that. So, you know, no one's coding all this stuff in 3 minutes. This is a bunch of complicated logic, right? You can easily mess up every line by being off by 1. So I knew there was something better, but I just couldn't figure out what it was, so I just went for this. Yeah, basically did a bit mask for all the spots where we're going to carry. Loop through smallest digit up. We check if we carried before 2 digits ago, and then we check if we need to carry now. And then we just have a bunch of casework. We know what digit we need. If we carried before and we have a digit of 0 and the carry is 0, then it's not possible when we fail. Otherwise, if we carried before, we need to like subtract 1 from this digit. Based on whether we're carrying now, we either add 10 or not. There's another weird case with the goal being 19, where we need to drop to 9. And then this is the number of ways to build that goal. Yeah, so this is not the best solution. All these things are error prone. I didn't have this for a while until I figured out that was a problem, and so on. Oh, and then we subtract 2 at the end because we don't want to count 0. It has to be positive integers. So for example, for 15,005, our solution will count 15,005 0 and 0 15,005, but we need to subtract those out. So we just subtract 2. So pretty simple there. Let's see. Yeah, so there's a much more clever approach for this problem, where you just think about, okay, what is Alice doing? Alice carries 2 over instead of 1 over, right? So what Alice is really doing is she's doing 2 separate additions, where one of the additions is the even digits and one of the additions is the odd digits. So for example, this addition, what is it? Let me see. 2039 plus 2976. And then she gets 15,005, right? Well, what she's really doing is she's really doing 23 plus 27, which makes 50. I'm messing up the spacing. Hang on. And then she's also doing 0.9 plus 96, which makes, what is this, 105, right? So she's really making 50 and 105, and then she's combining those digits together. So you have 105, and then you have 50, and then you're getting 15,005. Yeah, and that's what she's doing. So if you're this clever, which I was not, you can basically just take the number, extract out the even and odd digits into two separate numbers, and then now you just have the normal problem of how many pairs of integers add up to x, which is obviously just x plus 1, because you have 0 and x, 1 and x minus 1, all the way through x and 0. We need to count 0 in this case because you can interleave a 0 with a non-zero to get a non-zero. And then you subtract 2 at the end. So I think, if we look at, for example, SSRS's code, I'm sure it will look like this. Yeah, you build two numbers. For even digits, you build a, and then you build b for odd digits. A plus 1 times b plus 1 minus 2. And that's the solution. And this is the type of solution that you could finish in 3 minutes, as opposed to something like this. Anand mentioned he had something kind of similar to this, where he did basically a DP on the carry states. And that's another solution where basically it's going to take you a while. More clever than Neil hype. Yeah, this is the big brain solution. Yogesh, to go back, you can check the VOD here. It's going to have the wrong title, unfortunately, but it's just it's under recent broadcasts. You might have heard an echo for a second because I opened that link. Oh, actually, no, it should be fine. Can you go over the DP solution? Yeah, so the DP solution is just this bitmask solution. You just take this bitmask solution, and then you realize that the only thing you really used in the mask at any point is the bit 2 indices ago. So you just DP on the last 2 bits of the mask. Like, that's the only state you need to remember. The last 2 carries, whether you did or not, and that's your DP state. And the rest of it doesn't depend on the other bits. A plus 1 times c plus 1, that's just because, for example, for this problem, you split up into 50 and 105. What we want is 51 times 106. The reason is for 50, there are 51 solutions. There's 0, 50, this 149, all the way through 50, 0. This is 51 solutions, right? So it's plus 1. The reason that we allow this 0 is, for example, when we have 0, 50, and then for 105, let's say 105, we pick like 40, 65. If we interleave 0, with 0, 50 with 40, 65, the 0 won't end up being a 0, it'll end up being a positive number. So this is allowed. The only thing that's not allowed is interleaving zeros from both sides. That's why we subtracted 2 at the end. I guess it is... That's why there's this minus 2. Yeah, let's see how sys tests are going. Okay, looks like I passed A through E. That's good. Yeah, I'm pretty confident in my F, so I think we're good. And yeah, SSRS got everything, so this was a very impressive performance right here. So good stuff. Oh well, thank you CS Do It for the gifting 2 subs. Awesome. Mango Lassie says, how am I 7th before Fs get judged, even though I missed extra registration? Well, now you're 9th, so maybe that answers it for you. It looks like you're probably gonna go down every time I refresh. Oh no, it looks like this time you're still 9th. But yeah, we'll see. Yeah, thanks again, CS Do It. How long have I been doing competitive programming? I've been doing it for a long time, since somewhere like mid to late 2000s, so over 10 years at this point. Yeah, I think F is also hard. It's a problem where I just stared at it forever until I finally figured it out. It took me almost an hour of staring at it. I mean, yeah, 40 minutes to 1 hour 31. Yeah, Crow, well, I mean, you know, I took a break in the middle, so it wasn't like straight years. All right, another hydrate. What's my typing speed? My typing speed it's definitely pretty high. It depends on you know, the tests that I'm taking, but it can be anywhere from like 120 to 150, 160. Crow, you did it for 3 months and got burnt out. When was the last contest you did? Well, if you feel stagnant in competitive programming, you can take a little break and then come back. It's totally fine. I think F is the kind of problem where just trying different ideas until they work is a good strategy, which introduces a lot of variability. Yeah, it definitely involved just a lot of different thinking about different ideas before ending up with a solution. Yeah, people are asking me where I study or work. I work at a startup called Ramp. We're a super fast growing fintech startup. If you're interested in startups, and if you are able to work in the US, feel free to ping me. But anyway, let's go to problem D. Oh, Crow, you haven't entered since 2 months ago. Yeah, I do imagine a lot of people in chat aren't able to work in the US though. So that might be a big filter. Anyway, so problem D. We've got n positive integers that sum up to s in decimal. Alice sees the board. Oh, thank you, Megibite, for the gifted sub. I keep getting ads for Ramp on Instagram. Nice, that means we're doing a good job. All right, so Alice sees the board, but accidentally interprets the numbers on the board as base 11 integers and adds them up. Who does that? Like, what is wrong with Alice? She's been just messing up all of her numbers, like, a ton here. Anyway, never mind the problem statement. What numbers should Bob write on the board so Alice's sum is as large as possible? Okay, so we got 100 test cases. S is pretty big, it's up to 10 to the 9th, N can be at most 100. Okay, so basically, yeah, we can think about some examples. These samples are pretty helpful actually to think about it. If you think about it more, you know, for example, 97, there are different options we could do for 97, right? If we don't involve any carries, then the results will all be the same. Like, it doesn't matter if we do 70 plus 27, or if we do 96 plus 1. If there are no carries, you know, we'll end up with 9 times 11 plus 7, right? Which is 106. If we think about if we actually decide to do a carry, so let me close the file. So this is B, this is C. Thank you, Shawu, for the sub. Oh, this is a lot of subs. Awesome. Yeah, thanks everyone. Appreciate it. Okay, so yeah, we're looking at 97, right? So one option is, like we said here, 70 plus 27, which leads to 9 times 11 plus 7, which is 106. Now let's try what happens if we do a carry, right? Let's say we do 89 plus, what is it, 8. This leads to 8 times 11 plus 17, which is only, what is that? 105, right? Yeah. And now we know this is less. So let's think about what happened here. Why is this less? Well, we moved the 9 total in the tens digit, where here we have a 9 in the tens digit and a 7 in the ones digit. we move that to an 8 in the tens digit and a 17 in the ones digit. And the 8 gets converted to 11, or the 9 gets converted to 11, whereas the 17, it only stays as an extra 10. So we lost 1 by moving values down from the tens digit to the ones digit. So intuitively here, we just want to do as little carrying as possible, if that makes sense. So again, this problem is about carrying, right? So basically, yeah, we want to do as little carrying as possible. So for example, for this test case 97, the best we could do for 97 is we could do 10 plus 10 plus 10. So there are 9 tens plus 1 plus 1 plus 1, and there are 7 ones. So we could do 16, n equals 16, and still get a result of 106, if that makes sense. So what happens when n is at least 17? What do we do? Well, at that point, we have to break something up, right? So we're going to have to break up a 10 down into something smaller. And in fact, we can get from n equals 16 all the way to n equals 25 by breaking down one 10 into a bunch of ones. Basically, each time you take a 10 and you break it into a bunch of ones, you lose 1 from the result. And then each time you take 100 and you break it down and you have to carry, for example, let's see, you do 90 plus 10, then you're actually losing, what is it? I guess you're losing 11 from the result. I think that's right. So basically this kind of just screams greedy, right? And the first thing you can do is you can take your number and then break it into all of these powers of 10, right? And then after that, if you still don't have enough numbers, you can't break ones any further. So you find the smallest power of 10 that you still have that's bigger than 1. In this case, it would be 10. And you break that down. You can break it into 10 ones, because 10 ones isn't any worse than 9 plus 1, for example. And then you just keep breaking things down. You break down the smallest thing possible until you have enough numbers. Yeah, and that's my solution here. So basically just yeah, make a list of powers of 10. And then I just go through them in reverse order to break down the number. So this will just do, this whole loop will just do the stuff here. And then while it's still too small, I find the minimum power of 10 that's bigger than 1. So check all the ones that are bigger than 1. Assert that we actually found something. Let's erase that one. And then let's add 10 copies of that divided by 10. And I just keep doing that until I have at least n numbers. Now the problem is I could have more than n numbers, and that's actually fine. If we have more than n numbers, we'll just compress a bunch of them into one number by adding them. And that won't be an issue because we shouldn't have any carrying. So for example, if we have this, which is 16 numbers, but we only want, let's say 14 numbers, then we would just end up with something like this. I guess plus, and then we would end with, well, I can just show here. Yeah, we would end with 3 for n equals 14. Because basically we took 3 ones. So instead of, this is kind of unintuitive. Instead of this, we compressed that down to 3, so we got 14. And that's pretty much it for this problem. So a nice and simple greedy ultimately, but it takes some thinking through, what does it take to maximize the number? And it's really just minimize the carrying. And if you have carrying, keep it in the lowest digits possible. I'm on my way to becoming a full-time streamer. Yeah, I don't know if we're quite there. Might need a couple thousand more subs, but it's all good. I think Anand says, I think there's a less obvious case that it's worth covering specifically for carrying, where you turn a 10 into a bunch of 1s. And then you can have lots of 1s. Maybe I missed it and you explained it already though. Yeah, I think I covered that. So we were talking about you know, if this covers n equals 16 for 97, but if you need more, you can take any of the 10s and break them down into 10 ones. And I mean, that is, that's what my code does here as well. Is it necessary that for each n greater than or equal to 17, we'll have a decrease? Well, if you think about it this way, there's no way you can get 17 numbers that add up to 97 without doing a carry. Because obviously you can have at most 7 numbers that have a positive 1s digit, and you can have at most 9 numbers that have a positive 10s digit, and that's only 16 numbers. Can C be solved by brute force? Not that I know of. I mean, you have 1,000 test cases with 10 to the 9th, so you can't even loop over all of the possible values of A. Unlock a random sub-emote is the same as choose a random emote to unlock. Yeah, I guess no, I think I have some sub-emotes in here. Like, there's this one. That's an AC emote. Oh no, there's more. You just haven't gotten there. Yeah. Yeah, they're tiered emotes. Because I can only add emotes. Like, I can't even add more than one emote to the first tier. Yeah, exactly. So it's not even up to me, it's up to Twitch. Okay, so that was D. Let's check standings again. Okay, so looks like we passed everything. Looks like everybody passed everything. I mean, there were no hacks at all. Yeah, so everyone is passing everything. So that's a little boring, but anyway, we've got 2 more problems. Someone did solve C with, well, maybe you can do something more clever than, you know, just looping over all A, but at that point you might as well find the real solution. Yeah, Rainboy is, yeah, he's the one who just clowns around on these contests. It's funny because he was very, very close to red, and then he just decided that he didn't want to be red. When obviously he's good enough. I think he's clearly good enough for at least IGM. I mean, I think he got 5th place at IOI, so. Anyway, what motivates me to compete after so many years? Yeah, I mean, I mainly just do it for fun. I think also, you know, streaming and putting out content on YouTube is also a fun way to stay involved. Show how I decided to not be purple. Yeah. Yeah, it looks like you've been pretty close a few times. 1860, that is close. Yeah, I did IOI a while ago. I did it in 2008 through 10, so a long time ago. So I was competing with Gennady every time. Oh, sorry to hear that, but hope you had a good time just like being part of it. I guess it was not in person, so a very different experience. Okay, so we've got 2 more problems. Corporate or startup, which is better? I definitely think, I mean, it's a personal decision. Personally, I definitely think startup is better. It's just a lot more, you know, a lot more going on, a lot more to learn, less bureaucracy to deal with, and just, you know, faster pace, and you have a lot more autonomy. But it is more intense. You know, it's the work-life balance. It's not as good as, you know, a big company. So different choices there. Hey, even value. We just talked through A through D, and now we're talking about E. But if you want to rewind, you can look at recent broadcasts here. Okay, so let's talk about E. We've got an array, A1 through AN, for our birthday. And these stories, man, it's just, I don't know. All right, so we're very proud of the array, and Bob is asking for operations. The first operation is update update a specific element to a specific value. And then the second one is a query: how many non-decreasing subarrays exist within this subarray? More formally, count the number of pairs PQ such that basically PQ is in between L and R, and then this is true. Okay, so I'll help answer these. So N and Q are both up to 2 times 10 to the 5th. And I will say at least this is a short story, and it's not, I really don't like when it's just like a giant wall of text for no reason. I would say that is worse. Okay, so N and Q are up to 2 times 10 to the 5th. We've got the array, the elements are up to 10 to the 9th. And yeah, basically all of these queries like you'd expect. So we need to output the answers. And yeah, this is just a very, very standard secretary problem. So I used my secretary template for this. For my secretary template, you have the actual secretary code here, and it depends on, this is all this code does not change. It is the same for pretty much every secretary. Only this code is what changes. This is the segment logic itself. And then when you're in your main, you need to set up the tree, build it with some initial values, and then do updates and queries on it. So yeah, basically here, the way we're gonna make this work with the secretary is you need to keep track of, you basically want to keep track of the number of non-decreasing subarrays in your segment, right? And then you think through, okay, so I'm gonna call that count. What do I need to know to do to like find count? Well, what happens, the operation you need to do is you need to join 2 segments, right? What happens when I join 2 segments? Well, my count adds the other segment's count, right? So the count is the sum of the counts, but there's also these subarrays that cross between the 2 segments. So when you have, one segment like this, and then you're combining with another segment like this, I cannot. Okay. You can get subarrays like this that now appear that cross between your 2 segments, right? So how are we going to count how many of these there are? Well, in order for any of these to exist at all, first of all, we need this thing less than or equal to this thing. So that tells us, okay, we need to track the first and last value of the segments. So let's track that. And then if this thing is less than or equal to this thing, how many ways can we go? Well, we can go as far as the longest suffix of non-decreasing here and the longest prefix of non-decreasing here. So we need to track those things too. So now we're tracking the count of non-decreasing, we're tracking the first and last values, we're tracking the prefix and suffix lengths. And now how are we going to update first and last? First and last are easy to update. Your first is just the left first and your last is just the right last. Prefix count and suffix count are a little more tricky to update. We need to know, for example, for the prefix, are we just taking the prefix here, or is the prefix here the entire thing, and we can actually extend into here. So that's why I also track the length. And then this turns out to be a self-sufficient set of data to track. So basically all the logic is here. First of all, if either segment is empty, then skip it. Now if both segments exist, first of all we check if last is less than or equal to others first. So other is on the right and we're on the left. Then our count is going to add our suffix count times the other prefix count. So for example, if we have a suffix count of 3 and they have a prefix count of 2, let's say, then we have 6 options for the crossing subarrays, because we can pick the start point as any of these 3 and the end point as any of these 2. So that's why this is just multiplying. And then that's count. Count is also updated here by adding the other count. Length just adds the other end length. First stays the same, last updates the others last. And then the only things remaining are prefix count and suffix count. So prefix count only updates if it is our full length and we can extend into the other one, which means, again, this same condition. In that case, we add the other prefix count. Suffix count has a couple of cases. So this is the extend into the other one case, and then otherwise we just default to the others suffix count, which is the right suffix count. And that's pretty much it. We just use this seg tree, and all this stuff is pre-written, and so we just initialize 2 segments with the array we're given, and yeah, update if needed and query if needed, and that's pretty much it. Anand, you got wrong answer for not using 64-bit. Yeah, gotta be careful with those n squareds. They can overflow pretty easily. I don't know how to do this problem with binary index tree, hydrate. It feels like if you can do it, you need something more clever, because this involves a lot of important join logic. And yeah, someone asked about updates. Updates are also just using this join logic. So an update just takes the segment, the node that's a leaf that corresponds to this index, sets that node, and then joins every ancestor of it. So that's a pretty standard seg tree operation. But that's basically, this is why I have my seg tree template like this. I just write the segment logic, and then I don't have to deal with any tree logic. I'm done. Oh yeah, if people are interested, I actually have a GitHub now, I'll put in the chat, where you can find a lot of my code templates. So segtree is in this one. This is called basic segtree. The reason it's called basic is because you can only update a single index at a time. So updates are on indices, single indices. There's no range updates, which would involve lazy propagation. Hey Scott, thanks for the sub. Oh, we got a pretty big streak of subs today. Do I use 32-bit types by default to be ever so slightly faster? Yeah, I could have just 64-bitted all of these just to be safe. It really doesn't matter. I don't think I even used a bunch of memory. Which one was this? E? Yeah, this could easily have been twice as much memory with no problem. So yeah, I mean, I just did that because these all are fine being 32-bit, but if you want to be safe, it's perfectly reasonable to make everything 64. What are my thoughts on define int in 64T? So first of all, I don't think anyone has ever done that exact combination. It's usually define int long long, because I feel like people who use int 64T tend to code better, in my opinion. They tend to have better coding style. And yeah, I mean, define int long long, it's just like, it's just why are you removing your own, flexibility in choosing your types? Like, you could just type int64T. I guess people have a hard time typing int64T or long long or whatever. Maybe that's what it is. Yeah, I also personally hate, like, I used to do this a long time ago, but I personally hate this because LL just looks really ugly. Like, at least in my editor, it's a little different, but it looks too much like 1.1 or II. Yeah, my editor it's pretty good because all of these look reasonably different, but in some fonts, all of these look the same, and it's just disgusting. If you're gonna do this, I would say at least do this so that you can tell it's an L. Yeah, I64 would be better too. Yeah, and I prefer using, so I would do something like, I64 equals. But I also don't do that, I just do this. And I guess the nice thing that I have is I just type int6 and then tab, so I don't have to quite deal with the underscore and all that. No, I don't use LL anymore. I used to use it like, 10 years ago, but not anymore. I don't think, yeah, I mean, okay. you can, if you really want to, you can do one for int 128. 6 isn't that hard. You just hit it with your index finger. Okay, so we have one more problem. This is like the kind of the prettiest problem, but it's also definitely the hardest problem. Define int java.math.big integer. Yeah, I mean, take it to the extreme, right? Okay, let's talk about f. So we've got an empty grid, n rows, m columns. Some of the cells are marked. Hydrate. I'm actually running out of water here. Some of the cells are marked, and no marked cells are adjacent to the edge of the grid. We want to fill out the grid so that every unmarked cell contains either 1 or 4, hence the title. And every marked cell contains the sum of the numbers in all unmarked cells adjacent to it. So it's important that adjacent is sharing a side, so diagonal is not adjacent. If you're not adjacent to any unmarked cell, the sum is 0. And every marked cell needs to contain a multiple of 5. So help find any such grid or state that no such grid exists. N and M are up to 500, and we're given a grid which is dots and x's. Yeah, so right, yeah, int, I guess we all take it for granted nowadays that int is 32-bit, but I don't know if it's like that strongly guaranteed, because it may have used to be smaller. Okay, anyway, so we got an example here where this is a yes, we can fill out the grid like this, and all of the x's end up being 5s. For example, this one is adjacent to this 4 and this 1, and so it adds up to 5. This one is a no, we'll talk about why in a sec. This one has nothing, so you can fill it out any way you want. And this is a more complicated one, and we can fill it out like this. Okay. Can I uphack your f on stream after explaining? Is your f wrong? I thought you said you guessed and it was right. You're not sure. Okay, we can take a look at it. Okay, so let's break this down. So every marked cell has to sum all of the adjacent unmarked cells to a multiple of 5. So what does that really mean? Well, let's think about this. Basically, 1 plus 4 is 5, right? 4 is -1 mod 5. And you can only have 4 adjacent cells. So what that actually means is the number of 1s and the number of 4s adjacent to it are equal. So let's close this. Let's close this. Let's see. I had a... Yeah. So I'll just steal some of this. So in particular, this cell and this, oh no, this cell and this cell have to be different. One of them is 1, one of them is 4. The reason is for this x, it only has 2 adjacent unmarked cells, so they have to be different. Same thing if you look at this one, it's this cell. If you look at this x, it's this cell and this cell. That's a lot of cursors. But yeah, this one and this one, they have to be different. And then if we look at this x right here, then this one and this one have to be different. One of them is 1, one of them is 4. So that's what's really going on here. So first of all, the most obvious constraint is that every x has to have an even number of unmarked cells adjacent to it. Otherwise, it's just immediately a no. That's why this case is a no, because this x has 3 x neighbors and 1 unmarked neighbor. So it's just a no. And then after that, there are 3 different cases of x's. One case of x is everything adjacent to it is an x. In that case, you don't have to worry about anything for that x. Another case is that it has 2 adjacent unmarked cells. That means these guys are opposites. And then there are 2 configurations of this, I guess. There's the across configuration like this, and then there's the diagonal configuration like this. And these are opposite as well. And then the last configuration is 4 unmarked. And if we didn't have this case, if we only had these two cases, or these three, I guess, if we only had these, really two, I guess, if you only had these cases, the problem would be a pretty standard solution where you have these pairs that need to be opposite, and so you make the opposite relationship into an edge, and you make a graph. And now you draw a graph with all these edges. Edges have to be opposite, so what does that mean? That means your graph has to be bipartite. And you can check if a graph is bipartite in linear time. So that would be a nice solution for this. And yeah, basically we're checking if the graph is bipartite. The algorithm to check, basically you just do a DFS, you build a spanning tree, and you just make sure there are no edges that kind of break the parity of your spanning tree. Like an edge that goes from even depth, or odd depth to odd depth. Yeah, so just simple DFS, but we have to deal with this case, right? And this case is tricky because there's a lot of different arrangements. Basically, you have to have 2 1s and 2 4s, right? So you could do any of these, right? You could do like 1 1 4 4, or you could do 1 4 1 4, something like that. Or you could do like 1 4 4 1. We could do 4 on the top. 1 1 4, like, and so on. There's 4 choose 2. There's 6, right? But there's no obvious relationship here the way there is for here, where it's like, okay, these two have to be different, and then we're good. And you can think about things. So I was thinking about, okay, let's say we solved all of the like 2 cases, and we figured out whether those graphs work, make sure they're bipartite, and then what if we just assign them randomly, and then we try to solve the 4 cases after that? Well, you can get in trouble here. So there's an example here where basically for this one, it has to be different from this one. Oh. This unmarked cell has to be different from this one, which has to be different from this one. It also has to be different from this one. Like, these are all a component together. So if you set any of these to a certain value, 1 or 4, that will decide what this one is. A similar thing happens here, right, with these and so on. And then if you notice for this x, all 4 things around this x have a bunch of other dependencies. So if we went and solved those first, there's no way we can guarantee that 2 of these will end up as 1 and 2 of them will end up as 4, right? We could have 4 1s, we could have 3 4s and a 1. There's no obvious way that we can set the other values to make this work. Anand, you want me to hack you, but you're not even going to be here. Okay, so yeah, so that doesn't work. So I ended up just staring at this problem some more, trying to figure out, what the heck's going on. And I started thinking about some of these arrangements, right? And I guess there's a couple more. I can write them out. So what is it? It's 4 4 1 1. That's 4 1 4 1. I think that's everything. Yeah. Okay. So one thing you can notice is there's kind of 2 different types of arrangements. There's these, where the equal numbers are next to each other, and then there's these 2, where it's like alternating. And I started thinking about, is there any reason we would want to use this type or this type? Is there any big difference here? And so I just started making some hypotheses and testing them. What if we try to go for this type always? And that turned out to not necessarily work. But then I tried out, actually, I don't know if I tried that. I might have tried this one first. But anyway, you can try only using this arrangement. And yeah, I actually will claim that if you only use this arrangement, where you do an alternating setup, that is always good. So yeah, so this is a little crazy. But basically, it's easy to set up that we only want this arrangement. Whenever we get an X arrangement like this, now we just have 4 edges, right? This is not equal to this. This is not equal to this. This is not equal to this. And if you want, you can go all the way around. You actually don't have to. Yeah, okay, make it less. Yeah. Then I see how somebody solved it. No idea how to prove that though. Yeah, so the implementation is pretty easy. You read the grid. We're going to check every marked, count how many unmarked there are. Make sure it's even. If it's not even, if it's odd, it's immediately no. Otherwise, we just add edges in that cycle in order. And this code handles both the 2 case and the 4 case. And then I actually assert that it is bipartite here. And this is my bipartite checker. So it's just a DFS, pretty simple. And then the solution, also pretty simple. We just go through the bipartite components, split it up by each half of the bipartite stuff. And then for the marked, we just set it to its 5 times half of its unmarked count. And then we put that. Okay, so this gets AC. So why does this work? So in the contest, I kind of conjectured this. I tried some examples. It looked pretty good. The only thing you have to run is this graph bipartite? Like I claim it is always bipartite, but why? And I tried a bunch of, not a bunch, I tried a few examples. Basically in the cases where you make an odd cycle, you can't actually fill out the X's properly. And after I submitted and I got AC, I came up with the proof. And so I'll present that to you. Okay. So yeah, so here's the proof. So basically, we're building all these edges, right? So what we're going to prove is when we build edges like this, where the 4 case is just these diagonals of edges. So you make a diamond, basically. I'm going to prove that graph is bipartite. So let's go for let's think about how there could be an odd cycle, right? So now we have 2 kinds of edges. There are diagonal edges like this, from here to here, and there are these across edges. So there's 2 types of cross edges, right? There's also this across edge. Either way, 2 types of edges. So basically the first type of edge is 1 coordinate plus or minus 2, other coordinate is plus or minus 0, right? No change. And then diagonal edges, both coordinates plus or minus 1, right? Okay, so if we think about this, in order to have an odd cycle, we have to have an odd number of cross edges. If we have an even number of cross edges, then clearly we have an even number of diagonal edges, because otherwise there's no way we can end up back at our starting point. So odd cycle if and only if odd number of cross edges in our cycle. Or rather, cycle is odd if and only if odd number of cross edges. Graph.solve returns true if it's bipartite. That's right. Okay. So now I'll prove that we can't have an odd number of cross edges. And this goes back to the setup in the problem. All the x's have an even number of neighbors. So the arrangements of the x's, they have to form kind of these cycle-like shapes, right? Where you can have this type of cycle, you can have a bigger cycle that goes around. You can have a cycle that intersects itself like this, right? But they have to have these, as long as it's not a single x, it has to have this cycle type of shape. And we just know that based on, parity and kind of how graphs with like all even degrees work, especially in a grid. And in order to have an odd number of cross edges, every time we jump through a cross edge, we are going inside or outside of one of these cycle things, right? So when we go from here to here, we just went inside. When we go from here to here, we went, I guess, we can count this as 2 layers inside, right? Or 2 layers deep. So every time we take a cross edge, our number of layers deep inside changes by 1, either +1 or -1. And that means that we can't have an odd number of cross edges in a cycle, because otherwise we wouldn't end up at the same level. Okay, so that's the idea, and that's kind of the thinking behind it. So that's why it will always be bipartite. Yeah. So kind of a crazy problem. I'm curious how many people maybe like had seen something like this. I wonder if SSRS had seen this idea before, because this is really, really fast, like 12 minutes. That's crazy. This took me close to an hour, and a lot of other people a similar amount of time. Actually, I guess Anand solved it quite fast. He maybe he had a good guess. You can look at his code in a bit. Hi, CSK. Yeah, hopefully that makes sense to people, the idea here. Kind of how many layers deep are you in? Crow Redeem Hydrate. I actually ran out of water, so I'll get some more in a second. Anand's code is pretty complex. I doubt he had this idea. Let's see. All right, I want to open it in the... I don't want this editor. What is that? Why did I get the hacking editor? Yeah, does anyone understand what's going on here? This is a little weird. Okay. Why Gennady? Gennady doesn't usually do div2s. Congrats on winning Hacker Cup. Unfortunately, I actually failed system test with that little bug, but it was close. It was close. Okay, what is this? This is like pre-written bipartite code, I guess. So that's fine. What is this? Oh, Scarlet S, you're one of the authors, right? Yeah. So I thought the middle problems were kind of hard. Like I thought C and D were quite hard. For C and D, I took a long time thinking about C. I didn't come up with a clever solution. That might be a lot of the reason why. D, I guess D was a bit more straightforward, but it took some thinking. Whereas C, I don't know. I feel like C was easy for me to mess up. And then B, did you intentionally set up the constraints to look like you could XOR all these numbers, but you can't because of this? Yeah, B was super troll. Yeah, exactly. No. Okay, well, I mean, it is my bad because, you know, I shouldn't be submitting this junk, but I just did this loop and then I got a TLE. And I think Anand did the same thing, for example. Yeah. So we all got kind of trolled by this. We were just advised to add pre-comp to somewhat bridge the A to C gap. Yeah, I guess it's the type of thing where maybe for someone relatively newer, that would be an interesting insight to them to pre-compute the XOR. But yeah, I mean, yeah, I should just not be, you know, submitting something that bad. Or like, I should be reading these more carefully. There's no sum constraint. I think the thing that tripped me up is usually there's a sum constraint for these types of things, so I just assumed that was the case here, and it was not. Sorry about that. Yeah, no worries. Yeah, I thought F was nice, and E I felt was pretty standard. I mean, that's fine. I think it's a, you know, it's a good sort of variation to all of the digit carrying problems here, C and D. So E, you have a bit more of a standard data structure problem. So I think that's pretty reasonable. Oh, Shu, for some reason I thought it was 1E9. Yeah, then you would have to do the Edmod 4 casework, all that stuff. Um, yeah, you would. I think you. Yeah, that kind of makes sense. You would be better on an EDU round. I think it's fine here too, though. Like, I think Div 2 people should learn how to do this type of problem. Like that is, especially if they're getting through A through D. I think it makes sense. $10.48. Because I guess if you Google XOR first, yeah, I googled this. Yeah, and then I just checked this to double check my logic. The thing was, they do 1 through n as opposed to 1 through n minus 1, so you have to adjust it a little bit. But yeah. Okay, CSK, you're getting a little spammy. Please don't repeatedly at and say the same thing. It's up to you how you want to practice, which sites you like. I mean, do what helps you improve and go for that. But yeah, those are the problems. Let's look at Anand's code again. What is this? Okay. Oh yeah, that makes sense. Sure. So we're getting the unmarked. Sure. If it's odd, we fail. This is special. Otherwise, we might. If it's not by portrait, you fail. All right, now for special, what is going on here? Can you just do 6 minus x, 6 minus I minus j minus x? Anyway. Okay, so he... Also, this could have just been next permutation. What am I saying? Okay, so u, v the same, and a, b the same. Can constrain to be different? So you're just... Okay, so he's just... Oh, okay, so he's just guessing what they should be, I think. Oh, but maybe it's... Yeah, goto is not ideal, but if you have like really nested loops and you want to break out, then it can make sense. Often it's better to structure your code as a function that returns instead, if you can make it do that. Will I do some streams like when I upsolved that ARC round and gave thought process? Yeah, I could do some of those too. I think some of those get... The thing is, if I go into hard problems where it takes me a long time to solve, for example, if you just have me staring at this problem F for the 50 minutes that it took me, I don't know if that would be super interesting on stream, but for easier problems, it could definitely at least make sense. Upsolving would be cool. Yeah, I think upsolving is also probably good because it's should be less time just being stuck. Okay, so I don't know what all these can constrain methods are. It's kind of crazy. Let me see. So it goes right, left, down, up. Right, left, down, up. So can I feel like something like this could mess up his code. Can I make something where... Like this, maybe? I don't know if this will work, actually. So I basically want his code to print no when it should print yes. So let's see, we can make this our building block, I guess. Or maybe this. Okay, so is this actually gonna work? Oh, this is kind of annoying. Okay, wait. How can I do this better? I will... Alright, let's write a Python script to make this. Okay. This is not how you write Python. If okay, so grid is going to be, how do I make a long string in Python? It's like this times 10. Okay. And this doesn't. Oh, right. Python strings are awful. This is what we want. Okay. Yep, that's good. And really, I should just do this. What is range 1, 5? Yeah, so that's what we want. Okay. I guess I can do this. Okay, so I'm just trying to programmatically generate that pattern to see if this breaks on the solution. And how does this pattern work? It's like type, or like, yeah, which version is basically going to be I divided by 3 plus j divided by 3 mod 2. Yeah. And then yeah, grid I plus 1, j plus 1 is going to be this is going to be I mod 3 equals 1 and j mod 3 equals 1 XOR. What is XOR? This? XOR version? Print for row in grid, print join row. Let's try this with smaller numbers. 10. Okay, that looks pretty good. Why don't I do 10? I should do 11. Maybe we can do, this doesn't really matter, but we can do this. Okay, that's what we want. And we'll make it 500. Let's grab Anand's code. I don't like using the copy button because it seems like it's glitchy a lot. And let's try this. Oh, wait. That's not quite right. I need the... Ah, he found something. Okay. Then I don't know if I can break this. Yeah, it kind of just guesses. You need his early decisions on these special things to break his later decisions. So that might be a bit hard for this. Just catch up on chat. Did anyone check Jiangli's F? Let's see. I don't want this. I don't want that either. Oh, this is a little weird. What is this? Yeah, I think it's just the same idea. It's making these edges for diagonals the same way. And then I guess he just did the bipartite stuff much shorter. Yeah, you can just do it with BFS, I guess. That's basically what's going on here. Yeah, so this makes sense. This is the same idea. Okay, so yeah, we tried to break Anand's solution with this, but it might be harder than that. I don't actually understand how this works. Can add constraint on nodes. It's just, oh, I think it's just, does it break the bipartite? Yes. Yeah, we need something that breaks the future setup. And I guess maybe this example is too easy. Yeah, there might be something. I wonder if there is something that breaks this, but I'm not sure right now. Yeah, we're still here. Well, we've been trying to hack on institution, but I'm not sure how easy it'll be. The thing I tried didn't work. So yeah, I guess I'm probably gonna close out the stream soon. Did anyone have any more questions? Yeah, Anand asks. Yeah, exactly. Anand asked us to up hacking. Tips for beginners. I mean, just find problems that are good at your level, work on them, try, and then the important thing is try to think about them after you solve them. Think about how to generalize what you learned. So don't just think about how to solve X specific problem, but think about how to generalize the thought process further than that. Coconut water. If my rating is 440 and I solve A and B, should I upsolve C or should I work on reducing my time to B? I think you should, if you have the ability, you should work on both the problems that you did get and just understanding them more thoroughly and how you could do them more efficiently and more effectively, and then try one or two of the problems that you didn't get in the contest. I can upload this to YouTube. I might do it. Let me see if I can just like get a clean setup for this. I'll definitely at least upload my screencast to YouTube. Thanks for stream. Yeah, thanks for checking it out, Psychosynth. Thanks, Shawoop. In the meantime, you can definitely check out the videos here. Oh, whoa, thanks, Psychosynth, for the 1,000 bits. Yeah, that link should give you the replay of this stream, so you can check out the previous problems. It'll have the wrong title because I didn't update the title before starting. But yeah, it'll say round 708, but that'll be this one. Awesome, yeah, thanks for coming, Megibite. All right, sounds good. I'm gonna sign off, gonna grab some food. But thanks everyone for coming, and yeah, hope you enjoyed. I'll see you in the next one. And yeah, feel free to follow the channel for future streams. So I'll see you all later.